Hi, this is going to be a look development for VFX tutorial in Maya. I'm not sure how long the video will be, so there'll be timestamps either in the comments or I'll just put it in the description. I will just say firstly that different companies do look development processes differently, but this is just a method that I've used in a couple of mid-sized companies, so I thought I would just share it with whoever wants to watch this. So let's start. Maybe before I continue, I'll just quickly explain the purpose of look dev. So in Photoshop, let's say you've got a plate. So let's say you've got a VFX film and this is your single shot and you want to add stuff to it. Well, what you would do is you would take an HDR. So this is the raw HDR for that plate. And in my video called Lighting for VFX Part 1 HDRI Setup, we looked at, how to get our original. So what you see here, that is the raw HDR. So this one, that was shot using a Canon. And that's in Maya, so this little render. And then these background images are actually cuts from a few seconds of footage that was taken using the filming camera. So we wanted that, like this raw HDR, to look like the one used on plate. So then we essentially graded it from that to this. Oh, I zoomed in. Just zoom out. So from that to that. So what you might want to do if you were in a similar circumstance, you might want to follow that tutorial first and then use your HDR in your look dev scene. So for this, that's kind of what I've seen happen for sequences in films, where there's a particular sequence that has a certain HDR that can be used, then a lot of assets get look dev'd for that. But anyway, let's jump back into Maya. And so in the scene, I've got my asset, which is battle axe that I made. So this was actually just a raw model scene. So this is ready. So if you're working on a larger project or short animation, what you might want to do is have your asset modeled and in the origin, and then just group the models so everything's named. In fact, I did just import this asset in here. So you'll notice when I imported it, it came with the namespace. So if that's the same case, if that's what's happened with you, like and your project or whatever you're doing, then to remove the namespace, you go to Windows and to render, general namespace editor. You can select it, go delete and merge with root. So you notice it gets rid of that. There is also some history on this group, and what I mean by that is the translates. So I'm going to hold down spacebar, go to modify, freeze transformations. Okay, it didn't work that time. Okay, now it's zeroed out, and just for good housekeeping, I'm going to go to edit, delete all by type and history, so that should be fine. I don't think there's a shader on it right now, but okay, now there's a lambert. Okay, I also created a camera, so this will be our look dev camera, so I'll just call it render cam. And within there, you'll see 3 objects, and so let's look at them in the scene. I'm going to press 6 on the keyboard to display textures. So this is going to be our Macbeth chart. Similarly to what you just saw in Photoshop, if I go back to the plate, there is a Macbeth chart. And that's just to see how the light is affecting different different colors. So with the grey ball and the chrome ball and the Macbeth, so we're trying to emulate that essentially in our scene. So we have this sphere here, and this is the chrome one, so I'll just call it chrome ball underscore geo. And this will be grey ball. That just has a lambert on it. Grey ball underscore geo. And this is a Macbeth chart. I just went to Google, got a Macbeth chart, put a surface shader. So right click, assign favorite and surface. And that's just a flat material. And with the chrome ball, I put on an AI standard. So if you go to assign new favorite, Arnold, AI standard surface. Go to there, and when you create it, you can go to preset. Go to Chrome, wherever it is, and do replace. And that will be your Chrome. And what I did was I parented them. Let's just rename that. Parented them underneath the camera. So that means when I go to my render cam view, let's just change so I can see what's going on. Actually, I need to move these. Cool. So it means whenever I move around my camera, they stay exactly in the same place, which is pretty cool. Okay, so the next step would be, okay, we've got a locator there. So this locator is going to be used for the turnaround for the asset, so this battle axe. So that's why it's good as well for everything to be zeroed out. So the battle axe is in the middle of the world. So to create a locator, go to spacebar, create, and locator. And we're going to call this asset underscore locator. And I'm going to press E on my keyboard to go into rotate. I'm going to open up the channel box editor on the top right. I'm going to hold down Shift on my keyboard and press E, or you could select these by clicking and drag, right click, key selected. Then I'm going to go to a few frames along, so I'm going to go to 6. And I'm going to go to the y-axis and change that to 360. Right click, go to key selected. So that means that this locator, I'm going to scale it up just so you can see. Over 6 frames, it's going 360 degrees. Great. Okay, so now I'm going to select that locator, press Ctrl D to duplicate it, and now this one has no keyframes, but on frame 6, I'm going to hold Shift and press E and go to another 6 frames along. Do the same sort of thing. So put 360 in the Y, keyframe that. Because I scaled it up, it's got some history there, but I'm not really bothered about that. So I'm going to call this HDR underscore locator. So now I'm going to go back to frame 1, middle mouse drag and drop my battle axe into that asset locator. So now you can see over 6 frames it rotates a few different degrees, approximately 45 degrees for each frame. Going to do the same with an HDR, an IBL, I guess. So we go to Arnold tab at the top, go to lights, go to Sky Dome, rename this something like IBL, image-based lighting, and middle mouse drag that into HDR locator, so that when we get to frame 6, it will start rotating. It's hard to tell right now because it's got symmetrical cuts into it. I'm going to change the timeline to be 12 frames, and then what we can do is we could put an HDR in there. So I'm going to go to the attribute editor, and in the color area you're going to go find an HDR. If you don't have one, go to somewhere like hdrihaven.com. If you've got some spare money as well, I would say donate to them, because that's like the best website ever. And if they don't exist, it's going to be harder to find decent HDRs. So I'm going to pick an HDR. Mine are properly taken, so they've got multiple exposures put into Photoshop. That's essentially what you saw earlier in Photoshop. So this here, in fact, this image has been exposed up, but normally it looks like this. So when you take an HDR, you're basically taking a range of different exposures and then you combine them in Photoshop. I always forget where it is, but somewhere in Photoshop there is an area called HDR Pro or HDR Shop, something like that. Automate maybe. merge to HDR Pro. It might be that. I haven't used it for years because I normally always get given HDR, so yeah, you know, it just means I could be lazy. So let's name this file HDR, or probably the name of it. For the purpose of this tutorial, it doesn't really matter. So that's good. Color space is raw. That's also fine. And so the intensity don't change. That's one. The exposure, because I know this is dark, for me this is darker than what you would get on hdrhaven.com or somewhere like that. I'm going to change the exposure to 10 because I know it will be pretty much black. So on this battle axe right now is just a lambert. So I'm going to go to Arnold render, see what happens. This is default Maya scene, so I've not changed anything. Great. Cool. And you can even see the people in the background. Cool, so I'm going to save a snapshot of that. And with this asset, I'm just going to select the whole group and hold down right click and do assign new material, go to Arnold and assign standard surface. I will just say that there is metal on this and wood. So if we look at this, so it's a battle axe. So this bit is meant to be wood and the rest of it is meant to be metal. So if you're working on like a big feature film or something like that, then there's a chance that you would be asked to, or you would naturally apply metal, one shader to the metals and one to the wood. But I mean, it's up to you really. Because I textured this, I know that there is zero contribution to the metalness the metalness input to the wood. So yeah, I mean, this is a background prop anyway, so it doesn't really matter. Okay, so I've assigned that shader there, and I'm going to go to the shader area, rename it just for neatness. So I'll call it battleaxe underscore mat for material. And before I put in any textures, I'm just going to say that what you might consider doing first is if there's a lot of textures, you've got a lot of UDIMs or something like that, you might want to go to the Arnold tab and then go to the TX manager, because what will happen is if we put in the textures now, when we hit render, Arnold's going to try and convert all those text by default. It does this by default, otherwise you have to manually turn it off. It's going to try and convert all these images from whatever JPEGs, TIFFs into TXs. So what you can do instead is go to the TX manager and go to use textures in folder, and then pick your folder and just click select. It'll do it there, and then it'll say created 0 out of blah blah blah, and you just click create TX, so it'll do it first. That also means you can load in the TX file straight away, which is pretty good. So a TX file is a mipmap file, and it's basically it'll be the same, the result of the file will be the same, but it will just have different iterations of the image built into it. So when your asset is further away, or it's really far away, motion blurred, whatever, then it won't load that full resolution. So the texture for this battle axe, for example, is at 4K, but if we are really far away, if you've got a TX, it's not going to use as much processing power as if you were just using some sort of 4K JPEG, for example. Anyway, that's just my recommendation. So let's load in the base color. Before I do load in the file, I can show you in the Arnold tab it says auto generate TX, so that was already turned on. So that means that if I plugged in all my textures and hit render, if it's a heavy asset, then it could just kill Maya. Possibly has happened before. But I think the last time that happened, I was doing look dev on like something that was millions and millions of polys. So anyway, I found the file, my textures, and I've already converted this folder to TXs. That's why I didn't do it before. So I'm going to load in the TX. Just rename everything. So this is metalic underscore base color underscore image. And now I'm just going to do the same for everything else. So roughness, the reason I'm naming all of these, even though this is just a tutorial, is because people need to do that. Okay, so I am putting a metalness in, but as I said before, I did texture this myself, so I know that there will be no interference in the wood. The color space for the metalness and the roughness should be raw. My metalness and roughness are also 16-bit images. So 16-bit image has a higher color spectrum. It's got like 56,000 color values in comparison to 8-bit, which is something like 256. It's probably wrong. It's something like that, but it's not something I ponder every night. I just put in the wrong image. God damn it. Okay, so here I was putting in the bump map. It's called a height. It's coming from Substance Painter. So I'll rename this metalic underscore, I guess I should call it bump, even though it's a height map. The color space for that is also raw. The only one that will differ is base color, which, oh, it's raw there. Yeah, so the base color needs to be sRGB. If you're coming from Mari, it probably needs to be ACES CG because it'll be in linear. The difference between them is the gamma correction of 2.2. So there's 2.2 gamma correction applied to sRGB. sRGB is basically what you're watching on TV. Linear is basically, just imagine like flat image. This is not the video for that. Talking about this. Okay, so I've plugged everything in. I do also have a normal map, but I'm going to show you a trick in a second. So I've plugged in all of this. I'm just going to hit render and see what happens, and then. But first, actually, I'm going to up the res from half HD to full. And put a few more samples in. Okay. Cool. So this is what it's looking like now. I know it's not displaying correctly, but I was just loading in maps, just as you would. But I know that by default in Arnold, they don't get put in right. It would display correctly if they were all 32-bit images, and I will try and explain right now. So I'm loading up the hypershade. So let's take a look. The problem is, so let's look at this one. So the height, so this is for our bump. So it's going out alpha, but there's not actually an alpha there. So it's not really loading anything. So what we can do, because this image I know it's either 8-bit or 16-bit. I think this particular one is 16-bit. So it's just looking for like a float information. Well, firstly, there's nothing in the alpha, but it's just looking. Imagine having a black and white image. It's essentially the same thing if you point into the color channel, some float information. So if we do the same for each of these black and white images essentially. So the roughness, we could do out color R. For the metalness, we could do the same. You know, the reason for picking 16 or 8-bit rather than 32 is purely just memory capacity. I feel like everyone should optimize as much as possible. There was no point having everything like 8K 32-bit because no one cares. Like just make stuff that looks good. That's it. Like who cares if like you've filled up 200 terabytes of space? You know, we want to make stuff good and we want it to be able to run. There's nothing worse than trying to work on assets, you know, or shots on TV shows, films, whatever, that cannot run because then you can't do your job. It doesn't matter if it's like 50 million polys and the textures are like 2 petabytes. Who cares? Does it look good? It won't look good if you can't open the scenes. Okay, so before and after, so you can actually see now it's reading them properly. So that looks way better. Right, now here's the trick. The magic. Combining, I've not actually seen this elsewhere on YouTube, but I have seen a tutorial of someone saying that you can't do this, but you know, you can. So what we want to do is we've got, if you've textured in Substance Painter and then you view the material, it will be a combination of normal map and height map combined. And so we can actually do that here. If we create, so I hit tab to search and then search AI normal map. And then I'm going to search file, texture. Okay, that did nothing. That was good. Okay, search file, so we'll search for the normal map, TX. Cool, I'll rename that, battleaxe _ normal image. Something like that. And let's do the out color into the input. So this will allow us to control the strength. If we could use a bump 2D, and then if we were to do that, we'd have to change this to tangent space normals. And if you do decide to use a bump 2D node, there is one thing about doing what I'm about to do. You can't really control it. It combines them both, but then they're both controlled together. So if your normal map is stronger than your height map, then you won't be able to separately control it for some reason. It doesn't sit. I've never seen it working properly. If you do want to plug in a normal map from Substance into a bump 2D node, you'd put it into the value and then change tangent space normals and then turn off flip R channel. I believe that's the right method to do it. It just changes the way in which it's interpreted. But I've been using this AI normal map node for quite a while now, so I can't 100% remember. So then what we would do is out value from that into our bump 2D node. As you can see, there's no inputs, so you would think, oh, it doesn't want us to do anything. However, we can go to, where is it, show hidden, and then we get these extra options. So we want normal camera, because if you look, what's interesting is out of the bump 2D by default it's going out normal into the bump input, which is displayed here as normal camera. So essentially we're doing the same here. So we go out value into, I think I'm missing a tab, out value into normal camera. Cool. So now that's all connected up and that should be fine now. So let's just go back. I predict that it will be darker quite a bit. just because of what the normal map is doing. Yep. So I'm going to save that. We can actually now begin to add some AOVs just so we can see what's going on. So you go to the render sets, AOVs, press N, so that's for the normal map. We might as well add the specular, wherever it is, specular. If you want to look at your raw texture, you could do that. Specular albedo, sorry, diffuse albedo, that's the flat texture. Diffuse, that's the flat texture with light. Then indirect, direct and indirect, that's just the different light contributions. I guess I can add one of these. Let's look at the raw texture. Don't really need to though, because I textured this myself. So I'll press play. Obviously we get the same result, but we can look at the normal. So that looks quite strong to me. Diffuse albedo, you can look at my wonderful texturing. And the specular, it's darker than expected, but it's fine. Okay, so I think what we need to do is probably pull back on the battle axe. The normal map. I'm going to do a quarter of what it was doing before and then see what happens. So now we're beginning to do the look dev process, essentially. So it's a case of going between the hypershade and rendering and also color correcting things. That's what I found in all the jobs that I've done, is pretty much just that. Like, you get the textures. If you texture it yourself, you'll still end up doing this process. But all you want to do is start to bang down. So I hit tab, search for color correct, and you'll just want to basically just add these in betweens so you can basically alter your textures without going back into texturing. That's pretty much what the process is. So roughness goes into the input, and then the out color will still just want one string of information, one color channel of information. So there. And we'd probably want to rename this something like roughness underscore color correct, just abbreviating that. And you'll probably end up doing this for like each of your maps if you're look deving. But it depends what's needed, really. But it's always, even if you're not sure, you know, whether it needs to be done, it's always worth, you know, just having a play around. A lot of the time, I would personally say that the one that makes the most difference is adding a color correct to the roughness, because it affects the metalness as well, because the more you increase it. So if I increase this, let's say to 3 or 5, I'll do something extreme, so like 5. So you can see it's completely flat now. It's not so good. So, okay, so that's where we were. So the wood, I know it's mainly the wood that I care about, so I'm just going to highlight that area. And in this circuit, I know that the metalness does not affect the wood, so I'm actually just going to alter this roughness just for the wood. Well, just whilst looking at the wood, it will obviously affect the rest of the model. So the more I increase the gamma, the more it will increase the white values, basically. So for all these inputs, like the metalness, for all these scalar inputs, I should say, metalness, roughness, bump, pretty much all of them apart from the like subsurface and base color. Just imagine it's a black and white image with whites being on and black being off. That's the easiest way to think about all this stuff. So the more I increase the gamma of this roughness, mentally in my head, I'm just thinking this is whitening the image pretty much. So you can see there's before, so it's pretty wet wood. Now we're getting a bit more matte there. I think I need to increase the contrast. I'm going to jump all the way to 2. It's pretty extreme now. Maybe reduce the gamma. Cool, that's pretty neat. Let's let it render the whole thing. Getting a fair bit of noise as well. Okay, I think the wood's looking better now from that wet wood. Okay, let's say we're happy with that. Now it would be a case of looking at the metalness, I think. But I'm just doing this a little bit now just to give you an example of like the process I would take at least. In fact, this setup that I'm doing now is exactly the same process I've been doing very recently, you know, on a like something for the TV. So, you know, some companies will have massive pipelines, but principles are still the same. Principles like, so that if you copy this method for whatever you're doing, you know, you should hopefully get some good results. Because I'm kind of giving you a cheat code here, because some of this stuff took me a long time to learn, but you're being shown it within like 10-20 minutes. Okay. So metalness _ color correct. So looking at the specular, let's take a look at that. So it's pretty shiny. Let's just see what happens when we increase the gamma. Okay. Not too much. Not too much going on. I might just have to look at the beauty, because it is increasing the metalness, but maybe not the actual specularity. Because I know that the metalness is pretty shiny by default anyway. I mean, if I go back to the specular, you can actually make out the areas which are pretty matted anyway. I'm getting some noise there, but I would say that's just from the low red settings. But if you get noise like that and it doesn't disappear when you increase your render settings, such as, let's put this specular up to that, AA samples up to 6. Let's just let that render. Okay, it's getting quite slow now. But, you know, I will just show you, so it should disappear or reduce. Okay, these anomalies in that case are probably coming from, could be the height map or the metalness map. From looking at this asset in the past, it's not actually from the metalness, but there's a chance it could be. So if you diagnose everything else and you can't find a solution for that, like getting these white dots, I would say add in an AI clamp. And if you look at this node, it says min and max 0 to 1. So it's basically going to clamp the values. So you don't have to go back to texturing, but what it's going to do is just going to stop the color values from going over a certain range, basically. So what you would do is you would just plug in, after your color correct, if you have one, you would go out color, Actually, maybe you would do it before. You'd probably do it before the color correct. To clamp the colors first and then you color correct it. Or maybe after, I don't know, you'd have to test it. But you could just put this in and that can basically stop. It's because you get the white speck sometimes when the color values are too high, too extreme, and they can't be calculated properly. Let's just quickly reduce the bump. I'm going to half it and just see what happens, see if it reduces some of this white noise. I think that's pretty much done it. Let's take a look at the whole thing. Oh, yeah, the green, I don't think I mentioned that. The green is just coming from the HDR. It's coming from there. If you had an HDR that was similar to this, in fact, this in this circumstance, this HDR, what I did after grading it, I took it into Nuke, and what's the name of the node? I don't use Nuke too much, but it's like a color spill, something like, no, luminance key node, and then you can basically key out, just do a crude key out, because it's better that you don't have green screen it, because as you can see, that's why we're getting that. But unfortunately I couldn't find, like, I don't have Nuke on this computer right now, so I can't do that. So anyway, let's look at the before. So that's the very first import of all the textures, not changing any of the color space or inputs, and now we have that. So that's pretty shiny. It'd probably do with a bit more work, but you know, now is, I mean, it would need some more work, and I would probably continue working in that same that same particular way. In fact, I would probably add more contrast into areas. Actually, probably bring down the metalness because it is quite strong. It's darkening the whole thing. Yeah. Anyway, there's a lot of back and forward which you can end up spending hours doing this sort of thing. So just looking at the whole image, I was going to just quickly mention. So we've got the Macbeth chart, which is these are pure colors because this came from this just Google image on the surface shader. But you can see our chrome ball there, so that's exactly what's reflected, and this is the grey ball, or that's the lambert. Although I just remembered, I don't think the lambert is 50, it is 50% grey. I think the diffuse needs to be on 50, it's 0.5. So technically what we see here should be similar to what we see here, in theory. So if we look at these, I mean, they're rotated in a different way, but it's pretty close. But this is something just to keep in mind. So I'm just sort of rambling a bit. But now that we have those keys rotated for the locators, that means that what we can do is we can actually render out a sort of turntable for our asset. The first 6 keys would be your 360 for your prop. Oh god, I hate the snapping in Maya. It's so incredibly annoying. But you can see as I scroll through that I can get a 360 in 6 frames of this HDR as well. So anyway, I'm going to leave it there because this video has probably already gone on for long enough. But I hope that helps. You know, obviously any opinions I said in the video, they're obviously all of my own. And this is just a method that I've been using at some of the companies I've been working at as well. So I hope I found it useful. The battle axe model as well will probably be on TurboSquid, so I'll put a link below as well if you wanted to invest in that. But other than that, I hope this video was useful. Cheers.